Mr. Newbie here, and today we're going to talk about measurement. We're going to get specifically into measurement and woodworking, but we'll talk about other measurement types also. There are two main measurement types used in the world. The first one is metric, and that's where you're using millimeters, centimeters, meters, kilometers, stuff like that. And then you have what is known as the imperial system or standard or English, and that's where we're using feet, inches, yards, miles, like that. So in woodworking, we always use inches and fractions of an inch, okay? So we'll be getting into fractions. When you measure something, you can use anything as a measurement device. It would be called a unit. I could measure something with this dry erase marker, and from the beginning to the end would be my unit of measurement. So if I needed a piece of carpet for the classroom here, I could put this down on the ground and go all the way across and say it is, 92 dry erase markers long, and go the other way and say it's 63 dry erase markers wide. But that doesn't make sense, because if I call the carpet store and say, hey, I need a piece of carpet that size, they're not going to understand what dry erase marker measurement is. So that's why standards have been developed around the world, so that we can share information and it be the same and correct. So I want to talk about inches, mainly fractions of an inch, because most of you will already understand inches, and that there's 12 inches in a foot and 3 feet in a yard. But when it comes to fractions, a lot of high school students struggle. And it's because you were taught fractions way back in the 3rd, 4th, 5th grade, and you used it quite a bit, and they taught you about it and getting common denominators and all that stuff, and then you haven't had to use it, okay? And some of you have, depending on your math teachers and what you do, but I want to focus on fractions of an inch, because in cabinetry we get down to 30 seconds, okay? So first of all, you need to understand what a fraction is. A fraction, let me give you an example, 5/8. That fraction right there of 5/8, what's the 5? What is the 8? When I ask students that, they'll tell me the 5 is the numerator and the 8 is the denominator. And then I say, well, define denominator. What does that mean? And they'll say, oh, that's the bottom number. But that still doesn't tell me anything. Okay? So what I want you to understand is that the top number is how many from 0. All right? How many from 0. And the bottom number is how many possible. Okay? How many possible. So if you divide an inch into eighths, you have 8 eighths, because 8 eighths is equal to 1, your inch. And when you divide that into 8 parts, and you measure 5 of those parts, 5/8 of an inch, you've came over 5 of the 8 available. You come over 5 of the 8 possible, so that's why you get 5/8. That's why it's called 5/8. I'm going to go through a process of drawing an inch, breaking it down into its parts, and you will see how that works. So the first thing I'm going to do is I'm going to draw something that looks like this. That is my unit. And over here at the beginning, I have nothing, so that's going to be 0. Okay? But all the way over here, this is 1 inch. Now this is an actual 1 inch. It's expanded so you guys can see it. But this is going to be 1 inch. So over here, I would have 1. Okay? Now, turn 1 into a fraction. Pretty easy. It is 1 over 1. But we don't use that, okay? That's just 1. But I want you to understand that, because that bottom number of 1 is important. So we're going to divide this inch into 2 parts. So there are 2 parts, okay? And it may not be exact, because I'm not measuring this, I'm just drawing it. But now we have 2 parts possible. So what's our bottom number of the fraction? It's a 2. How far are we from 0? We're 1 part, right? So that would be 1/2. See how that works? Now, we have smaller things than half. So let's divide these parts in half. We're going to divide this one and this one in half. So, now we have how many parts? 1, 2, 3, 4. So 4 parts, those are our fourths or quarters. So we know that the bottom number is a 4. Top number, how far from 0? 1. So that is 1/4 or 1/4. 1, 2. So that's 2/4. But reduce, that gives us 1/2. And then we have 1, 2, 3/4. And if we go all the way, 1, 2, 3, 4/4 is equal to 1. See how this is working? Let's go a step farther. We're going to divide these in half. Now, how many parts do we have? We have 8. 1, 2, 3, 4, 5, 6, 7, 8. So, the bottom number is 8. Top number, how far from 0? 1/8. 1, 2 eighths reduces to a quarter. 3 eighths. 1, 2, 3, 4 eighths reduces to a half. 1, 2, 3, 4, 5 eighths. Remember earlier I started with 5 eighths? This is where 5 eighths is. Because you have 8 possible and you're 5 from the start. Okay? 5 eighths. 1, 2, 3, 4, 5, 6 eighths reduces to 3/4. 1, 2, 3, 4, 5, 6, 7 eighths. And then 8 eighths equals 1. You see this? Pretty simple. So now let's talk about the next smallest one, which is 16ths. So if we divide these 8s in half, now we have 16 parts, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our bottom number is 16. So 16, 16, 16, 16, 16, 16, 16, 16. Now I know these numbers are getting close to other numbers, but I wanted to draw this big enough that you could see on the camera. So here we go. First one, this would be 1/16. 2/16 reduces to an eighth. This line is 3/16. 4/16 reduces to a fourth. 5/16. 6/16 reduces to 3/8. 7/16. 8/16 reduces to a half. 9/16. 10/16, 10/16 reduces to 5/8. Then we have 11/16. 12/16 reduces to 3/4. 13/16. 14/16 reduces to 7/8. 15/16, and then 16/16 reduces to 1. So that's how an inch is broken down to 16ths. So what would our next smallest number be? What would this line right here be? That would be a 32nd, okay? Now, as we get into cabinetry, I expect you to know, not actually tell me that 25 32nds. 25 32nds is actually just past 3/4. I know that because it's one we use a lot, but just understand that halfway between 7/16 and a half, that there is a 32nd in there. And sometimes we have to split those, okay? Because we want to be very precise in cabinetry. Now, let's look at this and let's see some patterns here, okay? What do you notice about all the top numbers? All the top numbers on these fractions. What do you notice? They're all what? They're all odd, okay? So the top number is odd. Well, what happens if you have a top number that's even, like, I don't know, 8/16? Top number is at 8, bottom number is at 16. What can you do with that? Well, 8/16 reduces to 1/2, so it's right here. So if you have a fraction with an even top number, it usually can be reduced. Okay? Usually can be reduced. What do you notice about all the bottom numbers? Bottom numbers are all what? R. Should be R. Bottom numbers are even. But are they just even? No, they follow a pattern. Remember up here we had that fraction of 1 over 1? That bottom number doubled to 2, doubled to 4, doubled to 8, doubled to 16, and then doubled to 32nd. Okay, making sense? So, the bottom numbers are even, but they follow a pattern. Okay, they go from 1 to 2 to 4 to 8, 16, 32, 64, 128, 256, and so forth, 512. But we don't measure that small in woodworking. 30 seconds is good, okay? So, what happens if you have a number though like 6? A bottom number is 6. So let me give you a fraction here. 2 sevenths. Okay, you look at that and the top number's 2, so you're thinking, ooh, I can reduce it. But you can't reduce 2 sevenths because 7 doesn't reduce evenly. But you notice bottom number's odd, it doesn't fit our pattern. Okay, there's no such thing as 2 sevenths on an inch. But what if I did 2 twelfths? And then you're thinking, oh, that reduces. I can make that into 1/6. Okay, top number's odd, bottom number's even. We're good, right? No, it does not follow the pattern of this 6 doesn't fall into our 1, 2, 4, 8, 16, 32. So there is no 1/6 on a standard ruler. Okay? So that makes sense? Hopefully it does. Let me show you one more thing. Okay? I think we've covered this pretty good, so let's go into another way to help you understand. Okay? So, what is that? No, it's not a circle. No, it's not a sphere. It's pizza, right? Use your imagination here. This is a pizza. You order a pizza, you have it delivered, you open it up, guess what? They forgot to cut it. How many pieces do you have? 1, right? So as this whole number, you are 1 over 1. That's a pizza. But you don't want to eat it, you got to share it, so you cut it in half. How many slices are possible now? 2. You eat 1, you ate 1/2 of the pizza. Okay, let's go this way. Now how many slices are available? 4. You eat 3 of them, you ate 3/4 of the pizza. Okay, let's keep going. Now how many slices do we have? We have 8. Okay, Little Caesars, I think they cut theirs in 8 slices. Maybe Domino's too. Okay, 8 slices. You eat 5 of them. You ate 5/8 of the pizza. Okay, let's go a step farther. Now how many slices does our pizza have? 16. Okay? You ate 15 of them. You eat all this. All that. You leave me one little slice. You ate 15/16 of that pizza. Okay? This also works for pie and cake. As long as you're cutting it in halves, keep having it. Okay? If you've ever tried to cut a pie or cake into an odd number of slices, it doesn't work. Someone always gets a little bit bigger or a little bit smaller piece. It's very hard to do. But even numbers, you should be able to hit pretty good. Okay, so that's my introduction to measurement. Okay, how an inch is broken down, what the top number means, what the bottom number means. The accuracy of we want to be within a 16th, and sometimes we deal with 30 seconds. And so hopefully that kind of helps you understand inches, fractions of an inch, and what their meanings are. So with that said, newbie out.